So, binomial theorem. So, basically, when we say the binomial theorem, we are going to be dealing with expansions. Yeah, we are going to deal with expansions, and from these expansions, we can have a greater deal. But you may find that sometimes we can use our local expansion of primary, senior one, senior two. But then when we reach to some harder expansions, it becomes very, 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 very strange for us to expand. I'm going to make this session very brief so that whatever that we are going to talk about, you understand it. Now, I know you might be familiar with some of the items. For example, when I say any number to the power 0, for example, p plus q to the power 0, you need to know that this is the same as 1. So any number to the power 0 is 1, meaning that if I have something like p plus q to the power 1, it remains that number. So it will be p plus q, which one can write as 1p plus 1q. Yeah. If you have something like p plus q to the power 2, p plus q to the power 2, or to p plus q squared, this is the same as p squared plus 2pq, then plus q squared. Wherever I don't have a coefficient, I can put 1. If you have something like p plus q cubed, it means that you will get what you have as a square. You multiply another p plus q. So normal expansion of this will give you p cubed plus 3p squared 2, then plus 3p 2 squared, then plus 2 cubed. But wherever I don't have a coefficient, I put 1. So these expansions are what we already know. Yeah, but you find out that most of these things, as the expansions as the power increases, it becomes very hard and very tedious for you to expand, and therefore that is where we introduce in what we call the Pascal'S triangle to show how best we can expand, provided the number is having a real integer or a positive integer, and not a fraction, not a decimal, not a fraction, not a negative. We can use the Pascal'S triangle. So someone called Pascal designed the Pascal'S triangle that we can use to expand most of the expressions. So in this case, we are going to see how we can use the Pascal'S triangle to expand most of the expressions. So it is from this that we generate a Pascal'S triangle, whereby we shall be basing on these coefficients, the coefficients throughout. We shall be basing on the coefficients to generate the Pascal'S triangle. So in this case, allow me show you how we come up with a Pascal'S triangle that we normally use in expansions. So Pascal'S triangle. It all begins with 1, because we know the first thing is when we have power 0 and we get 1. The another thing, when you do power 1, you get 1 and 1. So after this, that is where the system becomes nice from now. So another part, we shall have a 1. Then to get another one, we get this 1, we add a 1, we get a 2, we write it in the middle, then we write another 1, something like that. Then you write another 1, you get 1 plus 2, you get a 3, write it in the middle. 2 plus 1, you get 3, write it in the middle. Then you get a 1. If it is another power, we shall write a 1 here. 1 plus 3, you get a 4, you write it in the middle. 3 plus 3, you get a 6, you write it in the middle. 3 plus 1, you get a 4, you write it in the middle, then 1. If it is another expansion, we shall have 1. 1 plus 4, you get a 5. 4 plus 6, you get a 10. 6 plus 4, you get a 10. 4 plus 1, you get a 5. Then here you get a 1. You go to another one, you write a 1. 1 plus 5, you get a 6. 5 plus 10, you get a 15. 10 plus 10, you get a 20. 10 plus 5, you get a 15. 5 plus 1, you get a 6. Then you write a 1. You continue like that, like that. 1 plus 6, you get a 7. 6 plus this, you get 21. This plus this, you get 35. Yeah. This plus this, you get 35. This plus this, you get 21. This plus this, you get a 7. And then 1. So this one works for when the thing is power 0, when the thing is to the power 1, when the expression is power 2, when the expression is power 3, when the expression is power 4, when the expression is power 5, power 6, and power 7. So when the expression is power 7, you have to use this row of coefficients, and then you see how to juggle it out. So basically, the main thing is that the expansion that we are going to be looking at using Pascal's triangle, you need to just be knowing the rows. If it is to the power 2, which row do I use? You must use this row of coefficients. If it is to the power 3, you have to use this row of coefficients of the power 3. If it is power 4, you have to use this row of coefficients. If it is row of power 5, you have to use this row where you have the 5s. If it is power 6, you have to use this row where there are 6s. If you have power 7, you have to use this row where there are 7s. If you're with me on generating the Pascal's triangle, type a yes, and then we start immediately with the examples of solving these, of expanding using the Pascal's triangle. So basically, we are going to see how to use Pascal's triangle to expand. And I will begin with simplest ones. Use Pascal's triangle to expand the following. A P plus Q to the power 3, I'm beginning with this small one. B A plus B to the power 5. Let's begin with this one, and then I show you how it just works. Now, basically, if it is P plus Q to the power 3, yeah, for part A, we have P plus Q to the power 3. So first write the coefficients of that expansion. Coefficients, if it is power 3, you are going to go to the row of power 3. So the coefficients will be 1, 3, 3, and 1. On the Pascal's triangle, this kind of thing, you can easily get it in the head, or you can always generate it and then you expand. If all of you are seeing where I've gotten these coefficients of power 3, type a yes. From Pascal's triangle, if you've seen how I've gotten those coefficients, type yes. If you've seen where I've gotten those coefficients from, type some yes. So now, after getting these coefficients, yeah, you go to write the terms now. You have the coefficients, but then we have terms. The terms, of course, we have P and Q, but one keeps increasing as one keeps reducing. So the first one when you're expanding based on the terms, the first one begins with its highest power. So it will be p cubed highest power. Then 2 will start with a power 0. Then now we shall have p squared. This one will reduce and this one will increase by power 1, 2 to the power 1. Then now p will be to the power 1 when 2 is to the power 2. Then now p will be to the power 0 when 2 is to the power 3, implying that p plus q cubed is going to be equal to, we put a coefficient and a term, p cubed q to the power 0 plus a coefficient and a term, p squared q to the power 1 plus a coefficient and a term, p power 1 to q squared plus a coefficient and a term, p power 0 q cubed. So this is going to be equal to p cubed q power 0. It will be p cubed because q power 0 is 1. So we have p cubed only plus 3p squared q plus 3p2 squared plus q cubed. As simple as that. So this is the expansion, p plus q to the power 3. If you're with me on that, guys, type yes. That is how we use a Pascal's triangle to expand that. If you're with me, type a good yes. Type a good yes, because I will give you some simple exercise where I will prove from that we are on point. All right, without wasting time, we shall see how to use Pascal's triangle to expand part B. Let's go to part B. Maybe if one has not understood, you get it from part B. We have a plus b to the power 5. What are the coefficients of power 5? You have to check on your Pascal's triangle, coefficients of the power 5. We have a 1. You check on the Pascal's triangle, we have 1, we have 5, we have 10, we have 10, we have 5, and then 1. If you're seeing this on your Pascal's triangle, type yes. If you're seeing this on Pascal's triangle, type yes. Now, after getting these coefficients, then now we go to filling in the terms. The terms, it all begins with the first one having a raised power of 5. So we shall have a to the power 5, but b starts with the power 0. Then now we go to a reduces to power 4, while b increases to power 1. Then you go to a reducing to power 3, while b goes to power 2. You go to a increasing to power 4, rather to power 2, while b going to the power 1. Then we shall have a going to the power 1, while no. This one goes to the power 3 at this point. Then a to the power 1, b to the power 4. Then a to the power 0, b to the power 5. Implying that the expansion a plus b to the power 5 is going to be equal to, we just expand, so it's going to be a to the power 5. In other words, you just put in the coefficients, 1 into a power 5 b power 0, plus 5 into a power 4 b power 1, plus 10 into a cubed b square, plus 10 into a square b cubed, plus 5 into a power 1 b power 4. then plus 1 into a power 0, b power 5. So you open, it will be a to the power 5 here, plus 5a power 4b, plus 10 a cubed b squared, plus 10 a squared b cubed, plus 5 ab to the power 4, then plus b to the power 5. So if you were expanding it locally, it was going to give you a hard time. But because there you can easily get the coefficients from the Pascal's triangle, you can get the coefficients, and then we expand loudly. So that is it. If you're with me now, type yes. I'm going to do just more 2 examples, then I assign you what to do. If you're with me, type yes now. If you really have understood, type yes. Okay, so I'm going to do final 2 questions. Then I give you what to do. You are going to prove to me that you've understood them or not. Yeah. So expand to minus 3x to the power 4 using Pascal's triangle. Hence, evaluate 1.97 to the power 4, correct to 6 significant figures. Someone is saying when expanding, does the question specify the method to be used? They can say use binomial theorem. So it is up to you to see that you can use Pascal's triangle and other methods which we are going to look at within the binomial theorem. So we have begun with Pascal's triangle, and I've told you that it is used to expand those where you have a power as positive. But there are other methods that can be used to expand it. But we began with Pascal's triangle. So yeah, I'm specific. I've just specified so that you understand this. Use Pascal's triangle to evaluate 1.02 correct to 3 decimal places. Pascal's triangle. We are beginning with part A, 2 minus 3x to the power negative 4. What are the coefficients, guys? Someone tell me the coefficients. Coefficients, what are the coefficients? Of the power 4, we have 1, 4, 6, 4, 1. If you haven't understood where I'm getting these coefficients, you refer to the Pascal's triangle and you look at the 5th row. 5th row gives us the power 4. So what are the terms? Terms, I'll begin with the 2 to the power 4, 2 to the power 4, and then negative 3x to the power 0. Then another term, I'll have 2 to the power 3, and then negative 3x to the power 1. I'll have 2 to the power 2, negative 3x to the power 2. I'll have 2 to the power 1, negative 3x to the power 3. I'll have 2 to the power 0, negative 3x to the power 4, implying that my expansion of 2 minus 3x to the power 4 is going to be equal to, now we shall be putting 1 into 2 power 4 and negative 3x to the power 0 plus 4 into 2 cubed and negative 3x to the power 1 plus 6 into 2 squared negative 3x power 2 plus 4 into 2 to the power 1 negative 3x to the power 3, then plus 1 into 2 power 0 and negative 3x to the power 4. So this expansion 2 power 4, 2 power 4, that is 16, because negative 3x power 0 is 1. Then this one, you multiply, this will give you 9, because negative 3x cubed square is 9. So this is 9x squared times 2 power 3, which is 8, then times 4. All of this one will give you a negative, this is 8 times 4, 32. 32 times 32 times oh, where am I? I'm here. This is power 1, sorry, this is power 1. So this is 8, 32 times 3, that is negative 96, sorry, x. Then you come to this is a 4 times 6, 24, 24 times 9. It is going to give you positive. Why positive? Because negative 3x squared is positive 9. So this is going to give positive 216x squared. Then you come to this of a cube, 4 times 2, that is 8. 8 times 27, it is going to give you negative 216 x cubed. You have to take your time when you're multiplying or when you're entering this. Then finally, we shall have 3, negative 3 power 4, which is 81 times 1, that is plus 81 x to the power 4. That's the expansion. If you're with me on the expansion, type a yes. If my expansion is so clear with you, type yes, and I see what to add on. If your expansion is clear with me, type yes. If my expansion is clear with you, type yes. Whatever terms they give you, the first term begins with the highest power, it keeps reducing as the other one also increases. So it's a matter of you to be smart as you substitute. So they want us to use Pascal's triangle to expand, and after expansion, they want you to evaluate 1.97 to the power 4. So hence 1.94 to the power 4, this one you must, because now you cannot just evaluate anyhow. You need first confirm this to this. It must be transformed from this form to this form. So you must make sure that 1.94 takes the form of this. Now, to get 1.94, it's the same as when one gets a 2 minus, because you must make sure that it takes this form. You must make sure that it takes that form. Yeah, 1.97, sorry. So it is the same as 2 minus 0.03 to the power 4. You must make sure that the figure inside the bracket here takes the form of what is written here. So this is the same as 2 minus, you see here we have a 3 out and then another figure x. So we shall say 3 into 0.01, so that I can easily know what x is equal to, so to the power 4. So when we compare, if we compare with 2 minus 3x to the power 4, you're going to realize that the value of x is equal to 0.01. 0.01. So if x is equal to 0.01, it would mean that it would mean that 1.97 to the power 4, we've gotten the value of x as 0.01, substitute it within the expansion. So it's going to be 16 minus 96 into 0.01 plus 21.6 into 0.01 square minus 216 into 0.01 cube plus 81 into 0.01 to the power 4. So the moment you work on this, you're supposed to get the final answer, which is 15.06138.431, but they want the answer in 6 significant figures, so which is the same as 15.0614, and this is 6 significant figures. So that is how we would expand that. It's a matter of knowing that the moment they say hence evaluate, you have to make sure that what they want you to evaluate is in the form of the original expression that you expanded, so that you compare, you get the value of x, and that value of x, you substitute it in the expansion that you've got. If you're with me at that, please upload me a yes, and I give you another question. That's very good from Semanda. Can I rub it? Can I go to another example? Okay. Example part B. They want us to use binomial Pascal's triangle to evaluate 1.02 to the power 3. So what does this one equal to? You cannot just use Pascal's triangle when it is just one figure like this. You have to split it. So this is the same as 1 plus 0.02. You can see that it can be split and to the power 3, meaning that this one can be your A, this one can be your B. So they just want you to expand it or evaluate it. So we need coefficients first. The coefficients are, for the power 3, the coefficients are 1, 3, 3. What are the coefficients? 1, 3, 3, 1. Terms, the first term will be 1 cubed, then 0.02 to the power 0. Then 1 squared, 0.02 to the power 1. Then 1 power 0, then 0.02 to the power 2. Then this was 1 power 1. So the last time is 1 power 0, 0.02 to the power 3. So that the expansion 1 plus 0.02 to the power 3 is the same as, you first write this coefficient 1 into the whole of this. Since it is just 1, first will be 1 cubed. Then plus another coefficient is 3. 1 squared is 1, so 0.02 to the power 1, which is that. Then plus another coefficient is 3. If we put a 3, this one will be 0.02 to the power 2. Why I'm not including 1 is that this is 1. 1 power what? Whatever you power to 1 is 1. Then plus another coefficient is 1 times 0.02 to the power 3. So this is going to be equal to, when you expand that, it's going to be 1 plus, of course, generally, let me write you the final answer, 0.61208, which is the same as, if I conclude 1.03 to the power, 02 to the power 3, it's going to be the same as 1.061, since they needed 3 decimal places. As simple as that. So there are numbers which I want you to do for me related to what I've done, so that you prove your level of understanding of this concept, and we see how you can feature there. Who are supporting that I give exercise to you guys? Who support to have an exercise right now of what we've looked at? Because the work now we are left to look at, is those further expansions. So I want you to first do using Pascal's triangle, so that I see how you can apply it. Someone is like, just bring, we crash. Okay, let me see how you're going to crash. Part A, this is your exercise. I want you to expand P minus 2Q to the power 3. B, 1 minus X to the power 4. Hence, evaluate 0.99 to the power 4, correct to 4 significant figures. Another one, C, I want you to expand 1 plus 2ax plus x squared, the whole of that, to the power 3. The hint I can give you on this, consider like this one to be one thing and this one to be the other. So this, the whole of this one can be maybe your A and this one your B. That is the only hint I can give on that, so that you do on your own. Still, I want you to go further. You expand 1 plus 3x to the power 4, part E, 2x plus y to the power 4f. I want to expand 2x plus 3 of x to the power 5. So you expand this, and then you get the feedback to me either on my WhatsApp or on your WhatsApp group. So you can put, instead of discussing all those things I can be seeing, you better discuss such work, but you can start discussing some things there. Then 3 minus 4x to the power 5 up to a term in x cubed. Hence, evaluate 4.96 to the power 5, correct to 2 decimal places. I want you to do this work for me, and I check out what you have understood. I won't add on from here until the next login. I wish you the best, guys. We've covered binomial theorem, just Pascal's triangle, but we have just started that. We just started the unit, so we are still continuing. Wish you well, guys. Can I rub it off? Complete copying that, and we have it.
Master,
Yes, please.
now like on that part C, do we have to again expand A as it's so for in Pascal's triangle?
I said all this 1 plus 2ax, consider it to be a one thing. In other words, you'll be having 1 plus 2ax as one thing, then plus x squared as another thing. Then should. That's why you have said exercise. I want you to try.
Okay, sir.
And I see what you have gotten. Can I rub this work?
Yes.
Okay, wish you well for now. Nice time, guys.